Good afternoon, everyone. This is a pretty enormous talk, and it is probably more than you ever wanted to know about resource hints. This is a kind of, I guess, 30-minute trimmed-down version of a much bigger talk. So the next thing I want to do is give you this URL. That is the full slide deck for the 45-minute version. So for this slightly condensed version, we're going to get rid of a couple of things. But the whole point of this talk is to introduce resource hints sort of completely and start to give practical examples of how we can use them. This URL will be on the very last slide of the presentation as well, so don't panic too much. My name's Harry, and I'm a consultant performance engineer from the north of England. I tend to help clients, usually quite big clients, make their sites faster, make their applications run faster for the end user. Now, clients like these all have very different budgets, different requirements, different timescales. So what I wanted to do is look at the simplest, probably smallest, but most effective thing we could use and make a talk out of that. Because resource hints are a very, very easy thing to implement for customers and clients and websites of all different shapes and sizes. I'm also a member of the Google Developer Experts Network, so if anyone has any questions about that, find me during one of the breaks. And during this talk, we're going to see different types of slide. If you see a slide that looks like this, it's a pro tip, it's a little example or a summary. If you see a slide like this, it's time to panic. This is when we've got a bug or a caveat or a regression or something that's gone wrong or something that could go wrong. If you see a slide like this, just with a camera in the bottom right-hand corner, my suggestion there is quickly take a picture of this slide so you can sort of see it locally as I'm discussing the rest of the concepts. So resource hints. Who has heard of resource hints? Who knows what they are? OK, very few of us. That's good. It's exciting for me. Who has used resource hints? So those who've heard of it, who's implemented them on a live site? Almost no one. Amazing. So by the end of this talk, I guarantee if you have a website, you will be able to use at least one resource hint. Resource hints are primitives that enable the developer to assist the user agent in the decision process of which origins it should connect to, which resources it should fetch and pre-process to improve page performance. My God, that's boring. Basically, they're single lines of HTML that can dramatically improve the performance of your website. And I mean it, they really are just single lines of HTML. We'll look at these in a lot more detail, but the syntax is as simple as this. And these resource hints are all available to do things that help speed up navigation for the end user. Resource hint specification, I would recommend reading it if you ever get a chance. But the whole point of my talk is to take all the best bits, take all the good bits, all the weird bits, and put them into one presentation. So hopefully, at the end of my talk, you won't really need the spec, but of course, it's always there. But the first thing I need to tell you is this. These are hints. There is a clue in the name. The browser is not obliged to carry these things out. So if the browser doesn't think it has the time or the resources available, it can skip over doing these because if the browser was sort of mandated, if it had to do these, there is a risk it could make the current page slower. So every web browser will use its own heuristics, its own intuition as to whether or not it will run these hints. It makes them very safe to use. The hints we're going to look at, DNS-prefetch and preconnect, the first two, these deal with visits to new domains, right? Requests going to new or third-party origins. Prefetch and preload deal with fetching files preemptively, so actually downloading files moments before the user even needs them. And the final hint, prerender, this deals with building entire web pages in like a background process. So by the time a user visits that page, it has already been downloaded and built and rendered. So let's start at the beginning. DNS-prefetch. This is the simplest of all the resource hints. It's also the oldest. And what DNS-prefetch does is it resolves the IP address for a given domain ahead of time. Basically, work out the IP address for a domain before we actually need it. So this is useful if you know what domain you're going to hit, but you don't necessarily know which file you're going to request. The syntax is very, very simple. It's declarative. Link rel equals DNS-prefetch, and in this case, the href I'm using as an example is just YouTube. Support for this is pretty good, 81% browser support, so we can start using it pretty much immediately. But how would we use it? Why would we use it? Well, I think a good example is this, and this is an example from my own website. we've embedded a YouTube video in the middle of a page. Now, as a developer, I know the browser at some point needs to visit YouTube, but the browser doesn't know that until it gets to line 155. And that's way too late. That's happening just moments before the video is needed. The browser finds out it has to go to a completely different server. So when we download a file, in this case, a YouTube embed, we've got a load of steps that we need to go through. And the first one is DNS. What we can do is we can tell the browser to look at the DNS nice and early. So it basically works out that YouTube happens to have an IP address of this. Now, when we talk about DNS lookups, they're usually fairly fast, but I did some research. Common names can answer in closer to 80 to 120 milliseconds. An uncommon name may be more like 200 to 300 milliseconds. But more interestingly, very uncommon names that have to go across the internet through high sort of latency or packet loss connections, go through inefficient resolvers, we can be looking at up to 10 seconds just to find out the IP address of a domain. That's way too much time. Looking at an example of DNS-prefetch in action, we can see here all of these files have their DNS costs separated from the file download, kind of divorced and paid for early, right? We've managed to detach the DNS lookup only by a few sort of maybe tens of milliseconds, but everything counts. You'll notice on line, well, this line, the numbers are cropped off. 92, we've actually moved everything away from the file, and that's what we're going to look at next. Unfortunately, DNS-prefetch is actually implemented as prefetch in IE9. This leads to very interesting problems when you try to use prefetch, because they basically swapped the syntax around. Hopefully we don't need to worry about IE9 anymore, but we'll take a look at this in a second. The next one is preconnect. So the next hint we're going to look at goes a step further, and technically it goes 2 steps further. What preconnect will do is it will add on to DNS-prefetch, and it will go on to do your TCP handshake and TLS negotiation. This, again, is useful if we know our web page is going to hit a third-party domain, but we don't necessarily know what file we will need yet. And it follows the exact same syntax. Link rel equals preconnect, and this time we're preconnecting to Google Fonts. Support for preconnect is even better. It's currently at 84%, so we can absolutely start using this right now. And if we go back to the YouTube example, what preconnect will do is it will do the DNS we've already solved, and it will do the TCP and the TLS. This diagram right here is stolen straight from my favorite ever technical book. It's a free book, hpbn.co, but this shows the process of actually opening a secure connection to a server. This diagram doesn't show DNS. So the DNS, the 200 to 300 milliseconds, isn't shown here. But what you can see is doing a TCP handshake, 56 milliseconds. Making that secure connection, doing TLS negotiation, adds another 112 milliseconds. We've already lost 168 milliseconds just opening a secure connection. Add on another 100 milliseconds for DNS. We're looking at half a second, 200 to 300, sorry. We're looking at nearly half a second of latency. So my site, before I implemented preconnect, you could see that all of these connections are being opened immediately before we need the file. That's way too late. That's very inefficient. By turning on preconnect, adding a couple of lines of HTML to my head tags, this is what happens. We completely divorce that cost. So just by putting a preconnect resource inside the head tags of the page, we pay all this up front. So by the time the browser actually needs the file, it's already got an open connection to that server. Much, much, much quicker. If you want to capture really good browser support, much older browsers, you probably want to do a preconnect with a DNS-prefetch fallback. This syntax is completely valid, and it's a very nice and tidy way of doing it. But the only problem with this syntax is it just for some reason, just does not work in Safari, which is really annoying. But it is a bug. It's a temporary bug. You can see here my Safari example. It just hasn't worked. We can see we're opening the connection just before we need the file. But yeah, luckily, thankfully, it is a temporary bug. My friend opened the bug on WebKit. This will be fixed soon. But for the meantime, to get the browser fallback working today, we just need to do this. You have to double it up. It's a little inefficient. It's not very dry. But this is how you can hit really good browser support. Be careful with preconnect. Just because we can use preconnect, it doesn't mean we should preconnect every single domain that we ever hit. Only warm up frequent, significant, and known origins, things you know you're going to need. Things that you know you need, like Google Fonts or Google Analytics or Discuss for comments, for example. Opening too many connections can have a CPU and battery drain, because keeping TCP connections open takes CPU cycles. CPU cycles will drain battery, so just go careful. And finally, there's a really, really, really weird quirk. I'd say bug, but it's even weirder than a bug in Chrome, which means you can only ever do 6 concurrent DNS lookups at a time. I'm not going to say what it is publicly, because it is that weird. I don't want to embarrass anyone, but if you buy me a beer, I'll tell you what it is. There's a very weird bug in Chrome. Firefox is just completely, it just stopped working. There's currently a regression in Firefox 66 where preconnect just stopped working. It just kind of disappeared. Nothing really to panic about. This will come back. They're working on it. It was a simple regression. But if you are implementing preconnect and you notice that Firefox doesn't seem to be working, there was a regression recently. OK, so DNS-prefetch and preconnect deal with domains, hitting unknown origins, or hitting future origins. If we happen to know what file we need, we can actually download the file. So instead of just opening a connection, we can preemptively grab the file for the next page. Or technically not the next page. The wording in the spec is pretty clever. The specification says, downloading a file needed for subsequent navigation. So it's very crafty. The reason we say subsequent navigation instead of next page is because, firstly, it doesn't have to be the next page. We could download a file that might be needed in 5 pages' time. And secondly, if you're working on a single-page app, you've only got 1 page. So the reason they call it a navigation is so that browsers have to allow these to work in single-page apps. Where you don't have pages, you've got either views or routes or navigations. The syntax should be getting really familiar now. This time we say link rel equals prefetch. But the major difference we're seeing here is we're linking to a file, not just a domain, but a specific file. Support for this, pretty good, 82%. And I think a really good example use case for prefetch would be this. Let's imagine that we work for YouTube, which would be pretty cool. We're building the search results page, and we've built this grid of thumbnails, and we are 99% certain that a customer, a user, is going to click on one of these thumbnails, right? Because that's why they're there. When they do, they're going to go through to the video player page, and they're going to need videoplayer.js. They will need this JavaScript file. Downloading the JavaScript file from this page is going to add unnecessary delays. What we can do is we can be clever, and from the previous page, in our head tags, we can just drop link rel equals prefetch videoplayer.js. So now what happens is the search results page will download the JavaScript that the next page needs, and it will just drop it into the browser cache. Download the file, drop it into HTTP cache for later usage. The spec says the user agent should not apply pre-processing on the response and must not automatically execute it or apply it against the current context. Again, that sounds very boring, very dry. Basically, all you need to know is that prefetch is inert. Prefetch will not run the JavaScript. Prefetch will download it, and then it's the script tag or the module import that calls it that will actually execute that JavaScript. And I keep mentioning JavaScript. This doesn't have to be a videoplayer.js. It could be an image. It could be a font. It could be a CSS file. The key thing here is working out a rough user journey and using the previous navigation to download files for the next navigations. So yeah, it will just drop things in the browser cache according to the file's headers, its caching headers. Except those with the no store cache header, because you're not allowed to cache those things. And a resource will be revalidated before use if there are certain types of other header present, or, weirdly, if the file's 5 minutes old. Someone obviously just had to pick a number and said, well, 5 minutes. So if the file ends up being more than 5 minutes old, there will be a trip back to the server to revalidate it, and hopefully it will still come from browser cache. Important to know that these files are fetched with the lowest possible priority. Because prefetch is a file that might be needed on a subsequent page, it will not block the current page's rendering cycle. So what will happen is the browser will deal with the current page. It will make sure it's rendered, make sure it's built. Then when the CPU starts to die down and the network starts to die down and the user is interacting with the page, it will then look for all the prefetches and it will do those very, very last. So that means that, again, the hint aspect of this, the browser will decide if it's safe to do this. It means it's very safe for you to implement. An interesting thing I worked out, I kind of had this thought, and I decided to try and work out what the truth was. Picture the scenario. I'm on page A, and page A starts to download a really big file. And while that file is downloading, it hasn't finished downloading yet, I click onto page B. What happens to the prefetch if it isn't finished? Turns out the browser will continue doing it for you in the background. This means that if you visit a page, begin a prefetch, but leave the page, the browser will continue to grab that file in the background, which means no wasted downloads and no double downloads. What would be really bad is if, as you left the page, it stopped halfway through downloading the file and then started from 0 again on the next page. It will persist. This is really hard to debug. It's really hard to work out what's going on here because dev tools can't show you this behavior. I had to learn how to read TCP dump logs. I mentioned some weird stuff in IE9, how they implement stuff the opposite way around. Because IE9 decided to call dns-prefetch just prefetch, and everybody else decided to call prefetch dns-prefetch, they're completely the opposite way around. So it means that in IE9, you get this weird kind of thing where if you try to prefetch a file in IE9, it will behave like dns-prefetch, and all you will get is a warmed-up domain, DNS, rather. This is kind of annoying, but hopefully, we don't need to deal with IE9 much anymore. But just be aware of this weird kind of quirk. The next thing to look at is preload, and preload gets a little bit different. So once again, preload is when we know a file. It's when we are lucky enough to know the exact file that we're going to need. Now, I keep kind of stress the importance of the fact that these are hints, and the browser is allowed to choose whether or not it will do them. Preload's different, because about a year or two ago, perhaps, preload was pulled out of the resource hints spec and put into its own separate specification. And that is simply because of all of the resource hints we're looking at, preload is the only one that is mandatory. Preload is a mandatory fetch for a file needed for the current navigation. All the other hints, the browser is allowed to determine, I will do that, or I'm too busy to do this, so I won't do it. Preload is mandatory. The browser has to do a preload. Why would you use preload? Why would you need to download a file for the current page if the current page is going to download anyway? Well, the reason is it's to help us surface late discovered resources. And I'll give some examples of what a late discovered resource is in a couple of slides' time, but it helps us make the current page even faster. The syntax is similar, but a little bit different now. The top line looks familiar, but the bottom line introduces these new attributes. And it's these attributes that make preload so powerful. We'll talk through each of the attributes in order, and I'll tell you exactly what they do. But browser support for preload isn't as good. It's mainly, as you can see, kind of Chromium and WebKit browsers. We'll discuss some weird bugs with preload. Unfortunately, it isn't perfect, but browser support sits at 79%. So what is a late discovered resource? I keep saying this, late discovered resource. What does that even mean? I think my favorite, or one of the best examples of a late discovered resource, would simply be a web font. To download a web font, we need to download some HTML, which in turn downloads some CSS. Then we build the render tree, and it's not until the render tree has been fully constructed the browser knows it needs the font. So the font sits at the end of what is called a long request chain. This font is a late discovered resource. The same applies to background images, and background images might be really big, so now this entire process has taken 1.25 seconds. Is anybody building a JavaScript application, like a single-page app? A lot of people. That makes sense. It is 2019. Unfortunately, single-page apps make this problem a little worse. With a single-page app, what's going to happen is you download your HTML. That will download vendor and app.js. You've got to spend a bunch of time building the virtual DOM. Then that will apply styles to the page. Then you can build the render tree, and then you find the font. And this has taken 1.35 seconds now. This is taking way too long. But preload helps. Preload helps the browser to find these files sooner. So in my head tags, now all I need to do is this. Yep, I'll have app.js. That's going to be a normal script tag that gets discovered in a regular fashion. But I'm also going to preload my style sheet, and I'm going to preload the web font. This gets rid of that long request chain and now allows us to completely parallelize the whole process. So now the waterfall looks like this. 750 milliseconds. We've bought back a lot of time there just by adding 2 lines of HTML to the head tags. So let's talk about the attributes. The first attribute is the as attribute. The as attribute used to be optional, but has recently become mandatory, so you have to supply an as attribute. In this case, as font, because this is a font file, but we've got all of these presets available to us. The as attribute is mandatory because it tells the browser what type of file to expect. So it guarantees correct prioritization, it guarantees the correct application of CSP, it makes sure the response and request headers match, it does loads of stuff to make sure the correct request headers are sent for the accept header. It does loads of stuff. It's mandatory. What you can see here is that if you use the as attribute, DevTools will tell you what priority those files had. And that comes out of the as attribute. I can guarantee that a bunch of you have already thought this because all developers secretly want to be hackers. Don't try and be clever. Nearly every single web developer asks me, Harry, if we start with this valid syntax, but maybe change it to this, can we make things even faster? Can we download an image as if it was a style sheet? The thing is, you can't. Things go really badly wrong. First thing you'll notice is that all of these files ended up being double downloaded. And the first time around, all their priorities were set wrong. So doing this will it will cause things to blow up, and things get much, much slower. So this is a bad idea. The next attribute is the type attribute. This is optional, but it helps us in a very specific use case. There are certain browsers, and I'm looking at you, Safari, that support preload but don't support certain file types. So there's no point Safari downloading this WebP. But the thing is, unless we give a type attribute with a MIME type, Safari doesn't know that this is a WebP image. So what you can do here is if you've got a type of file that a browser doesn't understand, pass in the type attribute so that the browser will skip over it and not waste any bandwidth. The next attribute is the cross-origin attribute. So who knows a lot about CORS? Who knows about cross-origin? OK, good. I don't. I know nothing. I can't find a really reliable intro to CORS. But when you're calling resources that are credentialed, you need to make sure your preconnect and your preload know about that. So you need to use the cross-origin attribute for things like fonts, ES modules, that kind of thing. Now, because I don't understand the full intricacies of the CORS policy, I just keep an eye on console. Here's a pro tip. In Chrome, Developer Tools gives you a really nice holding hand. It talks you through everything you could possibly need. So I made a demo page where I got all of my preloads wrong. And what you can see here is the first error is telling me that I didn't use an as attribute, so it didn't work. The second one shows me that I preloaded a CSS file, but didn't end up using it. So I wasted some bandwidth there. And the third error is just showing that I was trying to pull a credentialed resource, a font, but I hadn't set the correct cross-origin policy, so it couldn't be used. So the moment you start playing with preload and implementing preload, keep an eye on console, because there's really valuable information in there. Now for the bad news. Chrome is currently quite badly broken, to the point where I am removing preload from client websites. They're working to fix it, but Chrome completely misprioritizes preload. It over-prioritizes it. So it dispatches preloaded requests before more important ones. I'll demonstrate with an example. My friend Andy Davies built a site, and this is what it looked like before preload. And this is healthy. This is good, because what you can see is we're downloading all of the CSS first, which is critical render blocking stuff, then all the JavaScript second. And probably around here somewhere, hovering here, off screen is 4 fonts. There's a bunch of font files. So Andy thought, well, I'll preload the fonts, make them arrive faster. Chrome went a bit overzealous, and Chrome dispatched those requests very, very first. What you can see is all of the fonts arrive before the CSS. The painful irony there is that a font is useless without the style sheet that applies it to the page. These fonts ended up stealing bandwidth from our CSS files, and this page got 400 milliseconds slower. The complete opposite of what was meant to happen. Andy and I are discussing this with the Chrome engineering team, and we're trying to get this fixed, but just be very careful of applying preload in Chrome, because it is a little broken. The next one, the big sort of level, like the last boss kind of thing, the big one, the big daddy is called prerender. And this is where we get onto very different territory. The first 2 resource hints dealt with domains. The second 2, they dealt with files. Prerender deals with entire web pages. What if you could tell a browser, hey, I think the user's going to go to this page next, so please go to that page, download it all, and put it together, and just hide it in an invisible tab. Just hide it in the background so when they click through, they get the page. Kinda. It's very complicated. We're going to go on a bit of a roller coaster ride here because pre-render has had a very interesting history. It was introduced, it was removed, it was reintroduced, it's been killed, it's been renamed. The syntax is very familiar. No extra attributes with this one because it's just a web page. Pre-render, the login page. Browser support's not great, 71%. It's mainly Chrome, and what you will see is that IE implemented it in IE 11, but realized it was so dangerous they didn't even port it over to Edge. They abandoned it. A good use case for pre-render would be a little further than the one we had earlier. So prefetch got the one JavaScript file for the video player. With pre-render, we could just download that whole video page if we wanted. So that by the time someone clicks through, it's already downloaded and waiting for them. But yeah, it doesn't work. They killed it. There's loads of problems with pre-render that nobody thought of until it was way too late. What if a developer pre-renders 25 pages? That's going to completely just get your fans on your machine just going crazy, right? It increases bandwidth utilization for both the user and the server. If it's rendering a page, all of a sudden, your Google Analytics shows you've got way more traffic than you really have. What do we do about animations and pop-ups and cookie banners? If these are all in hidden, invisible tabs, how does a user know that you need to maybe HTTP auth into the site? You can't do that. The scariest one is, what if you get man-in-the-middled? What if there's a man-in-the-middle attack and someone drops a pre-render into an insecure site? So while you think you're looking at the local restaurant's menu online, what's really happening is there's a pre-render that someone's dropped that's mining cryptocurrency. So that's why they killed it. Pre-render is dead. But not really. They brought it back and called it something else, which is nowhere near as catchy. It's now called NoState Prefetch. But not quite, because what they decided to do is, because everybody started using pre-render, people started using the syntax, and it exists all across the web, they decided to keep the same syntax. So you still type link rel equals pre-render. That's the API. That's what developers type. You type pre-render. The mechanism underneath it is called NoState Prefetch, and that is how it works now. That means that we've got complete backward compatibility. All these sites that did implement pre-render get it back because they've got the old syntax that still works, but it works in a different way. But basically what it means is when you type pre-render, it's not going to actually pre-render anything, which is a bit silly. I'm going to give a quick intro, a few minutes left, a quick introduction to what NoState Prefetch does. Think of NoState Prefetch as a recursive prefetch. So prefetch normally just deals with individual single files. With NoState Prefetch, you're pointing at a web page. And what will happen now is that web page is like an entry point, kind of like a weird front-endy, very in-the-browser package.json kind of thing. Everything inside that HTML page will now be downloaded. So you just do pre-render page B, and the browser knows to go through page B and download everything it finds inside of it. The key thing is it won't put that page together. It won't actually render anything. So the syntax looks like this. Again, just goes in the head tags. And if I do this, pre-render will get executed with the lowest possible priority because, just like prefetch, it needs to happen in idle time because it might be used for a next page. It's not vital to this page. So here you can see that after the blue vertical line is the page's load event. After the load event has fired, the browser goes and looks for all the pre-renders and starts executing those. So I'm really keen to stress that the syntax is still the same. The syntax is still the legacy pre-render, but underneath it's called NoState Prefetch. Right, very last section, tips, tricks, and gotchas. Really quickly go through some little weird things we can do. The first one's my favorite. We can deploy all of these as HTTP headers. So we're currently putting them in the head tags, but we can actually deploy them as HTTP headers. In fact, Google Fonts do this for us automatically. If we've linked to a style sheet on fonts.googleapis.com, that file knows that next we're going to go to fonts.gstatic.com. So it pre-connects that domain for us. You can do this yourself. A colleague and I did this on a client website. We started to deploy these as HTTP headers because they execute a little bit sooner. We found really remarkable results. We found that the real-world metric showed a 400 millisecond improvement on average, but for the 95th percentile, pages got 1 second faster just by putting a pre-connect in HTTP headers. The bad news is Edge only supports the HTTP header for preconnect, so you can't do the HTML preconnect. This is really annoying, because deploying HTTP headers is much, much harder than actually just writing a bit of HTML in the head tags. On the flip side, for some reason, Edge doesn't support HTTP headers for preload. This one doesn't bother me too much because we don't really need it as commonly. The last little tip is that we can generate these dynamically, and this is where it gets really interesting. All of these resource hints can be made on the fly with JavaScript. You can create them based on user interaction. So you can constantly dynamically change what you're pre-connecting or prefetching. And a really good example of this is a little library called instant page. That is a web address. If you go to instant.page, there's a tiny little JavaScript library. And the way it works is like this. Keep an eye on the link rel equals prefetch in the middle of that code, like the sort of the middle line of that HTML. As I hover these links, we will see that all of these URLs are getting prefetched. When we go and look at the network panel, it means that all of these pages have already been downloaded. They're now basically dropped into the browser cache. When I take one of those links, when I follow one of those links, that page was returned in 3 milliseconds because we've already downloaded it based on user interaction. So all of these resource hints can be either deployed as headers and generated dynamically in the page. I've gone 1 minute and 12 seconds over. The security's down here ready to kick me off. That was a really quick, condensed version of this talk. The URL on the left there is the full slides, the full 45-minute version, where I show you how to put all this stuff together into one big package and design a full kind of resource hint sort of strategy for an entire page. But yeah, thank you very much for your time.
Thank you very much, Harry.